Hello everyone, in today's video I'll introduce you about LSTM and RNN, a deep learning model that can be used to train the computers to generate a sequence of logical text. To train the computers to generate text, a sample text should be provided, and if the corpus given is today is Monday, then all the upper cases should be changed to lower cases so that the number of characters to be trained for are reduced. And the user can set the input size. And in this example, let's say we set the input size as 4, then the first input data pattern will be T or DA, and the output label is Y because it is the character that follows the input character patterns. And the second input data is ODAY, and the output label is the empty space, and the third input data is DAY, empty space, and the output label is I, and it goes on until all the input character patterns have been prepared. To prepare the training data as your earlier example, you need to extract unique characters from the corpus, and each character must be encoded to integers because the computers cannot understand the characters by themselves, but only integers. And for the next step, the training data should be normalized so that it scales from 0 to 1. And to normalize the number representing its character, the number can be divided by the length of the character set. And remember that I have omitted the spaces and new lines in the above example. However, they are included to the character set when it comes to the implementation. Once all the input data have been normalized, the output labels are one-hot encoded so that the model is not forced to predict the exact net character but giving probabilities for each output characters. So, assuming you have prepared your training data following the previous steps, now it's time to pass all the training data to the input layer of the model. The input data must be shaped as input size by 1. In this example, it's 4 by 1. And the LSTM-RNN model goes as follows. Firstly, LSTM layer is created with 256 nodes, and dropout is applied to the layer with 20%. And then LSTM layer is added with 256 nodes, and dropout is applied with 20%. And lastly, fully connected layer is added, consisting of nodes with the number of characters. And during the training time, you need to save model weights whenever there is an improvement, because in the case of crash, the training can be resumed from that point on. The extension of the saved model is in the format of .hdf5, and you can make predictions by loading the saved model. After training has been finished, you can load the best weights from the saved model to make the predictions. With the model weights, now you can generate a sequence of text by predicting the next character starting from an initial input pattern. And the initial input pattern can be selected randomly from the trained data. And let's say the selected input pattern is im or nd, and the normalized value for each character is passed to the model, and before it is passed to the model, it must be reshaped as 1 by the number of characters by 1, and the reshaped input vector is passed to the model, and it generates the probabilities for each characters in the vocabulary. And the next input pattern is chosen by removing the first input character in the earlier input pattern, and by adding the character from the classification set that has the highest probability. In this case, the character T has the highest probability at 0.18, 18%, and the normalized value for the character t is 0.875, which is the number 7 divided by the length of the vocabulary, which is 8, and the new pattern is passed to the model, and this process is repeated until it generates the number of characters that the user said. So far, we have learned how to train the computers to generate the human-like text. However, the corpus given as an example is too short, so we need a larger corpus. And there's a website that you can download some free ebooks called Project Gutenberg, and the link is as follows. And for this project, I have used Peter Pan, and before you train the corpus, you need to remove the terms of use before the start of the project and after the end of the project to make the performance better. And the input corpus, if you're familiar with the Peter Pan, it goes as follows. All children except one grow up. They soon know that they will grow up, and the way when they knew was this, blah blah. And next, let's see the result generated by the computer. Although if you look at the generated text box, so most of the sentences do not make sense. However, you can see that some do make proper words, like you want to, she said to, in the bed, and what is it, he cried, makes proper sense. And I have provided the code in my GitHub, and you can refer to the link in the description box below the video and try to code it by yourself so that you can fully understand it. And if you're first time to Python, I'll put the link to the video prepared for those who want to learn machine learning but new to Python. A step-by-step explanation will be given starting from the installation guide. So up to this point, we have covered about LSTM network that can be used to generate text for computers. Although the generated text by the computer is not perfect, you can see that it can be one of the ways to make a computer to generate a human-like text. So I want to finish off here, and thanks for listening. Bye.